Good morning. Good afternoon. Today we'll start with continuation of yesterday's topic, that is work energy method. Yesterday we discussed regarding the related concept and also the related equation. Work energy equation also we derived it yesterday, where R into S is equal to 1 by 2 W by G into V square minus U square. That is nothing but the work done is equal to the change in the kinetic energy of the body or any object. That is, the work done by the force is equal to the change in the kinetic energy of the object or the body. So now, as you have yesterday discussed regarding work done, that is force into the distance, and energy, that is kinetic and static energy, and that is the capacity to do the work. Simple way you can tell it as capacity to do the work, and power is the rate of doing the work. These are the three we are related and also we are derived the equation. Today we will start with some problems, and also yesterday we have not solved any problems. Today we will start with, first we will start with a simple problem and then we will continue with that. Now in this case, we take a simple body problem, that is a body weighing, just take down, a body weighing 300 Newton is pushed up a 30-degree plane by a 400 Newton force. A body weighing 300 Newton is pushed up at 30-degree plane by a 400 Newton force acting parallel to the plane. Acting parallel to the plane. If the initial velocity of the body is 1.5 meters per second and coefficient of kinetic friction is mu is equal to 0.2, what velocity will the body have after moving 6 meters? What velocity will the body have after moving 6 meters? That is, a body is on a sloping plane and it is pushed up by a 400 Newton force, and what is the velocity of that body after moving 6 meters? That is what they have asked you. Just to show the figure on this one, that is a sloping plane. It makes an angle of 30 degree, this slope, and there is a body and it will move to the forward direction. Its weight is given, that is 300 Newton, and a force of 400 Newton is applied, and it is pushing this block in the parallel to the plane. Now it moves a distance of around 6 meters. At that time, from point A to B, and the velocity at this point is given, u is equal to 1.5 meters per second. Initial velocity of the block is 1.5 meters per second. And what is V? Velocity at B. After moving 6 meters with this force, what is the velocity of that block is required to be determined by work energy equation. As you know, the work energy equation R into S is equal to 1 by 2 W by G into V square minus U square. That is, work done is equal to change of kinetic energy. That is a standard equation. Work done is equal to change of kinetic energy. Change of kinetic energy. So based on this, we have to simply determine the other parameters by drawing a free body diagram of this block. Now as you see this one, 400 Newton force is acting here, 300 Newton is acting. We have to calculate what are the other forces will be there. There is a normal reaction always for any body. So the component of this one in this direction will be this angle works out to be 30 degree, as this is 30 degree just by geometry workout, and this is component force is 300 cos 30, and a component force in this direction will be 300 sin 30. Sin 30. These are the component forces, and reaction is N is acting upwards, and as this block is moving in this direction, the block is moving in this direction, so the frictional force will be opposing that will be acting opposite to that. If you draw this free body diagram, your 50% of the problem will be solved. Simple thing is that the parameters are required to be substituted in that equation, you will get the unknown requirement. Now first of all, what is the normal reaction? You can see N is equal to, the vertical component only is acting, that is 300 cos 30. Okay, that is the N, and F is equal to, mu is given, I think, mu between these planes is given, that is 0.2, the data is given here, coefficient of friction is 0.2. So, F is equal to mu into N, that is equal to 0.2 into 300 cos 30. This works out around 259.81. N is 250. This is 259.81 Newton. Okay, and if you work out the F, it works out 51 point Newton. 51.96 Newton. I think I'll write it very clearly. You got the coefficient of friction, the friction force acting on it. You got the frictional force, 400 Newton is acting here, 300 sin 30 is acting in this direction. Now, first of all, you need to have the R. What is R? It is the resultant force acting parallel to the plane. You have to see the force acting parallel to the plane. So, therefore, 400 acting in right direction, I will take it as 400 positive. I am substituting all the parameters in this equation. And 300 sin 30 is acting opposite to that, 300 sin 30, and frictional force is also acting opposite to that, minus 51.96. These are the three forces acting on the object in the parallel to the plane, and that is multiplied by S. The S distance is given 6 meters is equal to 1 by 2 W. The weight of the block is 300 Newton. So therefore 300 upon 9.81, 1 by 2 W by G into C square I don't know. U square I know it is 1.5 meters square. And there is only one unknown in this equation you can get. As I told you in the beginning, if you are required to work out velocities, then the work energy method is the best and simplest way to do the problem. So from this, you will get the velocity of this object is 8.942 meters per second. Earlier the velocity was 1.5 meters per second. Now you got 8.942 meters per second after 6 meters by applying a force of 400 Newton on an inclined plane which makes an angle of 30 degrees. This is the only simple way, and the main thing is that in this equation, you are required to simply substitute in that equation. The parameters you have to work out by drawing free body diagram, and then just simply substitute in that. In case of Daylight principles, you have to assume the direction of the inertia force. That problem will not be here. Okay. So this is a very simple problem when I have taken it. Next we will go for the other problems, all the types of problems. This one is similar problem we have done in Daylight's principle, but the parameters asked in this problem are different. But this is also a good problem to take down. In a police investigation of tire marks, take down the problem. In a police investigation of tire marks, it was concluded that a car while in motion along a straight level road skidded for a total of 60 meters. Along a straight road skidded for a total of 60 meters after the brakes were applied. If the coefficient of friction between the tires and the pavement is estimated at 0.5. If the coefficient of friction between the tires and the pavement is estimated at 0.5, what was the probable speed of the car just before the brakes were applied? So this is a simple police investigation type problem. The data are required. You can work out from this one. So now we have to determine what is the speed of the vehicle before the brake was applied. Remaining all the parameters are given. We'll see how to solve this one. Okay. Now first of all, I'll show you this car is moving on a straight plain pavement, and this is a car which is moving on, and at this point I call it as the point A, and it moves after applying brake. It goes and stops at certain point, and I say this point is B, and this distance is S, that is equal to 60 meters they are given. It took 60 meters to stop. Earlier it was at certain velocity, I don't know, and suddenly brake is applied and skidded for a distance of 60 meters and it halts, and the final velocity of this vehicle is 0, and it skidded for a length of 60 meters on a straight road. There was a friction between the tires and the road surface, and what is the initial velocity based on that? The coefficient of friction between the tire and this one is given, that is taken as mu is equal to 0.5. Here the weight of the vehicle is not given. We will take it as W is acting here. It will remain same with the here and there weight of the vehicle, and the vehicle is moving in this direction. Okay. Now, first of all, you work out at the point weight is acting here. Always there is a normal reaction, N is acting here. There is a normal reaction, N is acting here. Those side also. So it is standing here, and there is a frictional force F acting in this direction. I need to work out first the friction. Weight is acting, very simple here. N is equal to W because it is on plane surface, weight is acting downwards, reaction should be upward is N. And F is equal to mu into N. Mu is 0.5 and N is W. You will get 0.5 W Newton. That is what the frictional force acting on that in this direction is given. Now all the parameters are given, only one force that is acting on that. As it goes to this one, there is a retardation. It is moving retardation, not acceleration. Retardation. It will be retarded. Goes on, reduces the velocity. Acceleration. Acceleration means the velocity goes on, increases. Here velocity goes on, reduces, and it becomes zero after steady. Now I have to write that equation, substitute the parameters. The standard work energy equation is equal to 1 by 2 W by G E square minus U square, the standard equation. Work energy equation. Now first of all, the resultant force acting on that is nothing but only F is acting. The F will be taken into consideration. What F is 0.5 W you got, you take frictional force. As it is in this direction, I will take it as 0.5 W. And the distance it is skidded is 60 meters. I will write this left side of the part, work done part. That is minus 0.5 W into 60. And right side I will write 1 by 2. W is the weight, same 9.81. And V square I know it becomes 0. And the initial velocity is U square, I don't know. These are the things what you come across. Okay. Now, solving this equation, you will get U is equal to 24.261 meters per second is the initial speed of the vehicle. That is when the vehicle is, before applying brake, its velocity will be 24.261 meters per second. Now you can convert this into U kilometers per hour. So for that you multiply 261. Meter is there. I want to convert it into 1000 divided by 1000 into 60 by 60 meters per hour. So you will get this in terms of 87.34 kilometers per hour. You will get the velocity of the vehicle is 87.34 kilometers per hour. That is what second problem, where the police will be able to determine the initial velocity of the vehicle to judge whether vehicle is limit within the speed limit. So this is how the problems can be solved. This is a important problem. Next we will go to the one more problem. This is also quite interesting, and second problem also is there. You go for third problem. You can take down. A small block starts from rest. I think first I will draw the figure and also dictate the problem. Anyhow, I think all of you might have taken this problem. I will draw the figure first because the figure is very important in this case. One block is rest at the sloping position and these angles are given. This distance is 4 meters and this distance is 3 meters, vertical height 3 meters, and it makes certain angle with theta with this. This point is A and this point is B, and the block may move to this point. This block is C. Now the distance what it travels we don't know, call it as there, and this is the point from A, the block is left, and as soon as you release that one, it starts moving downwards and it halts, it comes to this point and then it becomes horizontal. It is on the sloping now up to the point B. So due to the gravitational force, it achieves certain velocity and momentum up to the point B, and then at that velocity, if you didn't apply any other force, it may move up to certain distance and it halts. We want to calculate how much distance it travels, what velocity it achieves at the B, and how much distance it travels. That is what is asked in this problem. Just to take down the problem, I will dictate it and then I will solve this one. A small block starts from rest at point A. A small block starts from rest at point A and slides down the inclined plane as shown in the figure here. What distance along the horizontal plane will it travel? What distance along the horizontal plane will it travel before coming to rest? The coefficient of kinetic friction between the block and the plane is 0.3. The coefficient of friction mu is given, that is 0.3. Mu is 0.3. Assume that the initial velocity with which it starts to move along BC is of the same magnitude as that gained in sliding from A to B. I will read it again. Assume that the initial velocity with which it starts to move along BC is of the same magnitude as that gained in sliding from A to B. That is, whatever velocity it achieves at the point B by sliding down here, the same velocity will continue with that, and because with the same velocity, you can consider it as initial velocity to BC where it travels and where it stops. So the important thing is we are required to work out the distance S. Okay. Now we'll take up this problem. First of all, you draw the free wheel diagram for this block when it is on the sloping portion, when it is on the horizontal plane. What are the forces will act? Now one thing is that its weight will be acting. We'll take it as, I think weight is not given, so I'll take it as W. Okay, and whatever angle it makes, the same angle it makes theta with vertical, and this perpendicular to the plane is W cos theta, and this component is W sin theta. This is 3 meter, this is 4 meter, so automatically this distance 3, 4, 5 by Pythagoras, either you can calculate it, but you can directly write. The horizontal distance, the inclined distance it travels is 5 meters, and there is a normal reaction always perpendicular to the plane, and as the block is moving downwards in this direction, and it moves in this direction, horizontal plane, like this, the frictional force will be opposing to that. I call it as F1 because on inclined plane. And simply you have to substitute the parameters by assuming between A to B. A to B, we have to calculate the velocity at B, the first thing. That first step we have to calculate. Once you calculate that one, then you again apply that equation from B to C, taking this V as the U for this one, and this as V as 0. I can call it, this is VB, okay. This is VA that is also 0. Start from right there. Now what are the forces will act here also? The weight is acting downwards, that's all. And there is frictional force opposing to this, and there is normal reaction N2 and frictional force F2. I'll give separate notes because it is on horizontal plane. Now each free, I can assume this as free diagram of A. This is the free body diagram at C, this one. Now first of all, apply equation between A to B. I can write between A to B. What happens? The block is released, it slides down to the point B. That's all. Now first of all, you calculate what is N1. You can call it as N1, F1. So N1 is equal to W cos theta. Okay. This theta you have to work out. Okay, whatever the angle. And W cos theta, that is theta you work out, it works out 0.8 W N1. And F1 is equal to mu into N1, that is mu is 0.3 into 0.8 W, we get 0.24 W. 0.24 W. You got F1. This is required for this block. Similarly, I required for the other also. For this also it is required. Here also I can work out here. What is N2? N2 is equal to W vertical, and F2 is equal to 0.3 into W equal to 0.3 W. You work out for the second free body diagram that also. So you got this one and also that one. Now I will apply dynamic equilibrium as all the forces parallel to the plane acting on that. Equate them. Dynamic equilibrium. Okay, dynamic equilibrium. Okay, no problem. I'll write all the parameters into the work energy equation. 1 by 2 W by G to V square minus U square. What is the initial speed here? Is VA. Final is VB. Can take those parameters. Notations I have taken. Now, what are the forces will act on this block? W sin theta. It acts on that. And frictional force opposite. Only those two forces. So therefore, I'll take W sin theta minus F1 into the distance it travels is 5 meters. I have worked out. It's equal to 1 by 2. Weight of this block is W upon 9.81. VB square. I don't know. I have to determine. And this is VA square. Starting speed is 0. Here the only WW cancels here. This sin W sin theta. The sin theta component of this one will be 0.6 W. This works out, sin theta angle works out 0.6 W. So 0.6 W minus F1 to 5. I'll write one more time into W upon 9.81 VP square minus 0 square. W cancels. F1 I have to substitute here. F1 is 0.24 W. 24 W. So this W is common for both. So this cancels. The only unknown is VB. You will get from this one Vb. The Vb is the speed at point B. It works out 5.943. 5.943 meters per second. That is the velocity at point B. We got it. Next is that I need to work out. Now I have to consider between B to C. This what we work out is A to B. Next step is I have to work out from B to C. I think that I will work out here only because that part may not be able to see. If you have taken this one, I will remove this one because already I got VB is more important for me, other things are not necessary. I will rub this one. This equation may be there. I will rub this one. I will write here only. On that side, I think it may not be able to see. R into S is equal to 1 by 2 W by G square. Now, only thing in this equation, is Vp will be here and Vc square between B to C. What you have to work out is between B to C you have to work out. Now in this equation I already have worked out F2 and from what are the conditions are here available. Well, it is there at this point, no force is applied on that, no gravitational force is there. Because of the whatever momentum it has achieved, with that velocity it starts moving here. Because of frictional force between the floor and this one, it stops at the point C. But I need to know at what point it stops, what distance it stops. So therefore, the frictional forces are, the forces acting on the block are, one is the frictional force 0.3 W minus 0.3 W, that's all, into the distance S whatever it travels is equal to 1 by 2 W is same 9.81, only velocity Vc, the velocity at C is 0 square minus earlier velocity I have worked out 5.943 at B. I hope this equation is correct. Only this W cancels and you will get S is the only unknown. You will get the S in this equation. It works out 6 meter. It works out 6 meter from B to C. It travels by a distance of 6 meter. So the problems are very interesting and you can use work in this equation related to determination of velocity as well as distance. So this is the one type of problem I solved here. Now I'll solve one more problem on motion of connected bodies. That is also interesting, but sometimes 1 or 2 or 3 blocks will be interconnected by a string and they will be pulled up or pushed up. So that time how the forces will act, what are the velocities will be there, times and the distance it travels, everything we require to work out. So then directly I will take the problem on that. I think I can remove this one and we will go to the next problem. Go to the next problem, motion of connected bodies. I will explain you and I will also solve this problem on this topic. Okay. Take down this problem. Determine the constant force P. Determine the constant force P that will give the system of bodies. Determine the constant force P that will give the system of bodies shown in figure a velocity of 3 meters per second after moving 4.5 meters from rest. I'll read. Determine the constant force P that will give the system of bodies a velocity of 3 meters per second after moving 4.5 meters from rest. Coefficient of friction between the blocks and the plane is 0.3. Pulleys are smooth. So entire 3 blocks are there if they are moving for a distance of 4.5 meters from rest, and it achieves a velocity of 3 meters per second. So how much force I need to apply so that it can achieve that velocity in 4.5 meters distance? That is what you are required to work out. That is how much force I need to apply. This is a problem based on connected bodies. That is, this is some level ground, inclined, and there is a level ground. One block is kept over the upper side, level ground, and sloping portion, and this is inclined plane and plane horizontal plane. One block is at some point here, and one more block is here on horizontal plane, and it is being pulled in the upward direction, in this direction, by a force of P. I need to determine P. It is being pulled in this direction. So the weight of this first block, I can call it as A, block A, block B, block C for my notation, and this weight of this block is 250 Newton. 250 Newton. The weight of this block is 1000 Newton. Actually downwards. Weight of this block is 500 Newton. These are the weight of the blocks acting on that, and all these 3 blocks, there is a small frictionless pulley, and a string passes through that connected to this block, and here also one small pulley is there. It also passes through that. Connected to this. This is how the arrangement is made. And just it pulls in this direction. 1, 2, 3. All the 3 blocks will be moved in this direction. All these blocks are moving in this direction. So, if it travels a distance of 4.5 meters, all this, just I am showing you, if it travels to a distance of 4.5 meters, all the blocks will move, and its initial velocity is 0, and this velocity is 3 meters per second. Final velocity is 3 meters per second, and the distance it travels is 4.5 meters. So, all the 3 blocks will move at a distance of 4.5 meters. As they are interconnected, all the blocks will move with the same velocity and for the same distance. So therefore, for that, how much pull force I have to apply here? That is what is asked in this problem. Now, as my objective is that I need to determine only the force P they have asked you. But as you know that they are all connected by the strings, the string will be always under tension. Always the string will be under tension. So they have not asked you to determine what is the tension in the string. They have not asked you. So in that cases, you can apply the connected bodies principle so that T is common for all. It can be removed out. Directly you can apply one simple equation for all the three. You will be able to solve in one line the force P. So during examinations, it depends on what data they ask you, accordingly you have to solve. Otherwise, you can first of all determine the force P by applying connected bodies principle, and then if you want, they ask you to determine what is the tension in the cable, then write a equation for the one block with free body diagram, and that equation already you know what is P, only thing you have to determine tension in the cable. That way also you can do it. Okay. Now in this case I will solve it by both the methods. Just try to show you that one. Very simple. First of all, the parameters are required to be worked out here is that you need to work out. This is N1. I think you can see it, N1, and I can say NA. If you are seeing it is okay, this color, otherwise I have to use different colors. It's the color of board and both are same. Should not fail that you can't see this one. So I shall use a different color. You can take N1. As the blocks are moving in this direction, frictional force will act in this direction. I'll call it as Fa. In this class also, there is N2, NB, I call it as. This block is moving up, frictional force will be acting here like this. This block is moving this way, and there is a N3, NC, and frictional force will be opposing that. F. These are the free body diagrams I have shown you, and tension in the cable will be acting in all the points. Now what I have to do is that the tension in the cable should be is common, you can remove it. You can apply directly the principle of R into S. What is the standard equation for this one? Work energy is that R into S is equal to 1 by 2 W by G into P square minus U square. The same principle you can use it. Otherwise, you write the equation for all the three blocks separately and then solve one by one. You can get that. Now, in this, first of all, you see here, I will write a combined equation for both this one. First is what is N1? Here, N1 is equal to 250 Newton W. And Fa is equal to, what is the coefficient of friction between the block and this one is given 0.3. They are given you mu is equal to 0.3. You write 0.3 into 250. You will get Fa, frictional force at A, is 75 Newton. Similarly, for this block, you need to have the components. You have to work out this angle, theta. That angle you can get, the slope is given here. The slope of this one is 4,3, I think. 4,3. You work out the angle theta. You work out this angle is theta. And the component in this direction will be 1000 cos theta, and component downwards in this direction will be 1000 sin theta. You will get it. Okay. Now, first of all, I am calculating the frictional force. Now, what is NB? This is first, this is second. NB is equal to NA. The 1000 cos theta. This works out 600 Newton. Theta you work out that one. And FB is equal to 0.3 into 600, 180 Newton FB. Similarly for this one, NC is equal to 500 Newton and FC is equal to 0.3 into 500, 150 Newton. So all the parameters, this one I have worked out. Now simply I will substitute all the forces acting on that. Common is T, only T I will not take into account. All the other forces I will add in a equation by connected bodies. This is a problem on connected bodies. Otherwise what you have to do? You have to write an equation for this block, free body diagram. You have to write equation for this block. You have to write equation for this block. There will be one or two unknowns will be there. There are three equations. You can solve them. You will get the unknowns. So it is a lengthy procedure. In that case, what you will get? You will get the P as well as you will get the tension in the cable directly. But in this case, you will get only the force P. Now, what is the ultimate is what is the total force acting on the system? That is what I have to work out. Now, acting on the system parallel to the plane along the line is P is in this direction. I will take minus P. Okay, direction, and frictional force will be acting in this direction, positive. FA is 79 plus 75. Come to the block B. What is the force component of the weight will be acting in this 1000 sin theta in the downward direction plus 1000 sin theta, and frictional force is also acting downwards. FB plus this is FA. I will write in short FA, and this is FB also in the direction. FB is 180 Newton. I will write FB short here so that to understand where it comes. Those acting here, and come to this block C. Nothing else, only FC is acting, no other components. FC is in the right direction, that is plus 150 Newton. This is FC. These are the total forces acting on the system, entire system along the line, parallel to the line. And here it is horizontal, here it is inclined, this is horizontal. So along that line of command of force, all these things are right. And it has traveled a distance of 4.5 meters. I will write S is equal to 4.5 meters. Is equal to, you have to write this equation. I will write this side instead of writing that side. Is equal to 1 by 2 W. I need to add the weight of all the three blocks. That is 250 Newton, simple weights, and 1000 Newtons, gravitational direction, and 500 Newton. All the three I will add here, and gravity is 9.87, 9.871. You can take it. And in the bracket, as all are connected bodies, the velocity will remain same, either initial or final velocity. So therefore, I want to know what is the final velocity is given 3 meters per second. Initially starts from rest. So therefore, 3 meters per second into 0 square. Out of that, in this equation, there is the only one unknown is P. You solve this equation, you will get P is equal to, you will get P is equal to 1383.39. 1383.39 Newton. Okay. Very simple. In one equation, this entire problem is solved. Only thing is, in these problems, the drawing of free body diagram is very important. showing the frictional force, inertia force, all those things you should show properly. 50% of your problem is solved. And remaining is simply you have to substitute the related parameters in the equation and you will get the answer for that. So whatever the force I need to apply for this is that I have to apply a force of 1383.39 here, so that entire this system of blocks will move with a velocity of 3 meters per second after a distance of 4.5 meter when it starts from rest. This is what we have done. But the only thing is, if you want to know what is tension in the cable, though they are not asked here, but I want to determine what is the tension in the cable. So in this equation I didn't get that one. So I got the value of P. Okay. Now I'll remove this one. Just I'll remove all these things. Just I want for tension, I'll write an equation. This same equation holds good for this one. For tension in cable or where? For tension in cable, consider block A. Any one block you consider block A and write the equation, substitute in this parameter. Now, what is there? P is acting in this direction. I will take P as post minus 1383.39. Left side it is there. FA is acting in this direction, minus 75 Newton force. I am writing R for R value. And any other things are there? Nothing else is there. T is acting. Now I am considering only that free-body diagram for block A. T is acting in this direction plus T. These are the forces which are acting on this block. Only for one block I am drawing free-body diagram and I am writing the equation. And it has traveled a distance of 4.5 meters is equal to 1 by 2. What is W? Only one block, that is 250 Newton. You apply, divided by 9.81. In the bracket, P square minus C square. P square is 3 and other is 0. 3 meter square minus 0 square. That's all. In this equation, only there are two unknowns. One is, I think P I have not written. It is P value only. P we know it. T I don't know. Earlier what happens? P and T both were known. So now P I know it from this one. Only T I have to determine. You can determine T from this equation. I think I have worked out here. I'll see it. Okay. Solve it. This equation. You'll get the answer for T from this. Okay. This is how the problems are required to be solved on different aspect of this one, dynamics. So work energy method, most of all the varieties, I'm not saying 100%, but most of all the varieties of problems have been solved in short duration. And try to go through these problems. If you have any doubts, you can contact me by mail or by WhatsApp or by call. In whichever way you want, you can call me, so that I will be able to answer you and clear your doubts on that. So in the next class, again next session, I will take up the impulse momentum theory and also the related problems on that. Okay. With that, entire portion will be over for you. Thank you. Good day.